Hello, Math 109 students. This is part 3 of video covering 6.3 to 6.8. Several of the questions were involving solving log equations, and we went over how to do a lot of that in part 2 video, but this one looked a little bit tricky, so I wanted to go ahead and show you how to do this one. How do we're trying to get x by itself, but the way that we might need to do that is to get rid of the log by exponentiating both sides. So when we exponentiate both sides with an exponential, well, sorry, it wouldn't be a 2, with an exponential base x, because the exponential base needs to match the log base. So to get rid of a log base x, I use an exponential base x, and that cancels that out. So now I've got 49 equals x squared. And then I need to get rid of the, to get x by itself here, I need to get rid of the squared exponent. How do you get rid of a squared exponent? Use a square root. And that cancels that out, so x equals, remember you got to put plus or minus in front of that now, so x equals plus or minus 7. Okay, but I don't believe negative 7 will work because I don't believe a base on a log can be a negative number. So I think we just want the positive 7. I think we just want that to put in for our answer, not the negative 7. So let's just type it in and make sure that's going to work. So if we type in 7, then we get the right answer. All right. On this, this one might look a little tricky as well, but it's actually really easy if you can recognize that this already cancels. ln and e already cancel one another, right? ln means log base e, and so this means the exponent on e that gives you e with an exponent of x, so it just cancels out and gives you x. The ln and the e cancel out, so you just get x equals 6. That's all there is to that. All right, the next big topic in this section is properties of logarithms. All right, and here they are. Okay, so basically what this says is if you have a log and it is kind of a complicated logorand, so you have multiple things going on in the logorand that you can expand. You can expand this complex log into multiple simpler logs using the product property or the quotient property and even the power property. So if you've got two things being multiplied in the logorand, each one of those things can have its own log. Notice that the base doesn't change, it stays the same whenever you're going from the complicated log to the simpler logs. It's still the same base. All right, and the same thing that works for these logs also works for ln's as well, obviously. If you've got two things being divided in the logorand, then they can also get their own base, their own log. If the things are being multiplied, they're going to be separated into their own logs with addition. And if the things are being divided, they're going to separate into their own logs using subtraction. Now this follows the properties of exponents, because if you have an exponent, if you have two things being multiplied with the same base, what do you do with their exponents? You add their exponents. So that's why you're going to add the logs. And if you're dividing things with the same base, you subtract their exponents, which is why this turns out to be that you're going to subtract the logs. And then this last one down here, if you have a logorand that is to a power, then you can move that power in front of that log so that it's multiplying with that log. And that's also a property of an exponent, because a log is an exponent. And if you have an exponent to an exponent, you can multiply those exponents. A power to a power, you multiply the powers. So this power comes down and multiplies with this log in that same vein. Okay. Let's look at some examples. All right, we're going to expand this log base 3, and we're going to do that. The 2 and the x cubed are both going to get their own separate log base 3. So when we expand this, it's going to expand to a log base 3 of 2 plus a log base 3 of x cubed. But then, so that's good. But there's one more step we can take. That was the power property. I'm sorry, that was the product property. Now we can also do right here the power property, because that 3 is a power on that logarithm. It can come down in front. All right, so we're gonna write that. We're gonna take that 3 and move it to the front, and this is my final answer. Same thing with this log base 10. The 5, the x cubed, and the y can all three get their own log base 10. And I really don't like even the fact that they used it, that they wrote the 10 in this example. You shouldn't even write the 10, because if it's a log base 10, you should just write log and not even write the base. So that's what I'm going to do in my answer. So it's going to be a log 5, and it's understood to be base 10, plus log x cubed plus log y. Loggy. Okay, so now again, I have just applied this this product property, but now I'm also going to look for the power property to be applied to this power of 3 on this x. The 3 can move in front of the log, so that's my final answer. On number 4, the x cubed and the y are going to get their own separate log base 7. But this time, because they're being divided, instead of separating them with additions, with pluses, I'm going to separate them with minuses. So it's going to be log base 7 of x cubed minus log base 7 of y. And you already know that my next step, I'm going to take the 3 and move it to the front. So I'm going to erase the 3 there, and I'm going to write it in the front of that log, and there's nothing else I can do, so that's my final answer. All right, moving on. Here, the 5, the a squared, and the b to the 5th all get their own log base 4. When you have multiple things going on in a fraction, here is a very simple way to handle it. Anything in the numerator is going to be adding. Anything in the denominator is going to be subtracting in the final analysis. So this is going to be log base 4 of 5. I need some more room. I don't think I'm going to have enough room here. Let me do it up here. It's going to be log base 4 of 5 plus log base 4 of a squared minus log base 4 of b to the 5th. Okay, notice I used the product property and the quotient property at the same time. Anything in the numerator is going to be added. Anything in the denominator is going to be subtracted. All right, again, this is everything that you do to expand logs. Now, what are we also going to do? The power property on the 2 and the 5. I'm going to take that 2 and move it in front of its log. I'm going to take that 5 and move it in front of its log, like so. And that's my final answer. All right, on number 6, what you want to do with this root, square root 3, is rewrite the square root 3. I'm sorry, not square root 3, cube root, or third root. Rewrite the cube root as an exponent instead of a root. So I'm going to rewrite that as ln of 3 x to the what? To the 1/3, because a cube root you can rewrite as a 1/3 exponent. the index of the root goes in the denominator of the exponent over yz cubed. And now I'm going to rewrite it with its own log. So it's going to be each one of those things, 3 x to 1/3, the y, and z cubed. They're all going to have their own separate ln. Anything in the numerator is going to be added. Anything in the denominator is going to be subtracted. So ln 3 plus ln x to the 1/3. If you're comfortable at this point to go ahead and just write 1/3 ln x, feel free, go right ahead. I'm just doing this in 2 steps in case anybody's confused. Minus ln y minus ln z cubed. And at this point, I need to apply the power property, which means I'm going to take that 1/3 and move it in front of its ln. So the 1/3 is going to come down in front. And I'm going to do the same thing with the 3. So the 3 also comes down in front. And that's all I can do. That's my final answer for number 6. Okay, it's the same thing I'm going to do here. I'm going to rewrite the 3x minus 5. Instead of the square root of 3x minus 5, I'm going to rewrite that as 3x minus 5 to the what power? To the 1/2 power. Because the understood index of a square root is a 2, and that understood index of a 2 becomes the denominator of the exponent to rewrite the root as an exponent. And so now the 3x minus 5 is all grouped together. You can't separate that out because it's all grouped as one thing by the parentheses. So just treat that 3x minus 5 as one single thing. So the 3x minus 5 is going to get its own log, and the 7 is going to get its own log. So it's going to be log of 3x minus 5 to the 1/2 minus log 7. And then what am I going to do? I'm going to take the 1/2 and move it in front of its log, and that'll be it. Okay, let me go back to the first one, the very first one. I didn't like the fact that they put this one first, but that's why I didn't do it until now. I'm going to rewrite that 6th root of x. I'm going to rewrite that as x to the 1/6, and then I'll be able to do it pretty easily. It's going to be log x to the 1/6 minus log of y squared, and then just move the 1/6 in front of that log and move the 2 in front of that log, and that's it. All right, our what we just got done doing was called expanding logs. That is taking a complex log and breaking it down into simpler logs. But we can also go the other way. We can, instead of going from the left side to the right side, we could go from the right side to the left side. We could go from several simple logs. We could condense them, put them together into one more complex log. And that process is called condensing logs. Here is a written out strategy for condensing logs. If there's a number in front of the log, move it back to an exponent first. So this is basically just walking backwards from what we just did. Remember the last thing we did on the others was to move the exponents in front of their logs. Well, now if we go backwards, the first thing we're going to do is do the opposite of that. We're going to take the number in front of the log and move it to the exponent place. Then if the exponent is a fraction, then you're going to rewrite that as a radical. You remember how before we rewrote radicals as fractional exponents, but now we're going to rewrite fractional exponents as radicals. All right, if there's a number raised to a power, then just go ahead and simplify that number. So if you end up with like a 5 to the 2nd power, just write 25. Then condense addition back to multiplication and subtraction back to division. The final answer will have log written only once, and we'll have no fractions as exponents. So let's take that strategy and put it to the test. Okay. So if there are any numbers in front, like that one and that one, we're going to move them to the exponent spot. So that's going to become a 2 squared. And that's going to become an x to the 1/3. All right. So let's rewrite that. It's going to be log base 2 of 20 plus log base 2 of, but we're not going to write 2 squared because 2 squared we can just write that as 4 plus log base 2. And instead of writing x to the 1/3, we're going to write cube root of x because that's the same thing. And then we're going to put it all together into one single log base 2 by multiplying these 3 logarithms together as one thing. So 20 times 4 times the cube of x, that's going to be 20 times 4 is just 80. And then the cube root of x is just going to be the cube root of x. And that will be my final answer. Okay, same thing here. I'm going to take the 2 and I'm going to put it right here. I'm going to take the 4. I'm going to put it right here. Now you might say, well, why don't you put -4 there? I could. You could put -4 there and then change this to just this minus sign to a plus sign. But I think it'll be easier for you. I mean, you're going to get the same result regardless, but I think it'll be easier for you just to keep that as a minus sign and just take the number in front, just take it as a positive number and move it to the exponent spot. So then when I'm going to mark that out to make sure I know that I've already moved it. So now when I write my final answer, it's going to be one single log base 3 with this and this and this coming together. Now how are they going to come together? Since this one is plus, the x and the y squared are going to be multiplied. Since this is minus, the z to the 4th is going to be divided. In other words, the x, anything that's added is going to go in the numerator. Anything that's subtracted is going to go in the denominator. So when there's pluses and minuses going on, we're going to have a numerator and a denominator. So the x and the y squared go in the numerator, and the z to the 4th goes in the denominator. Let me write that 3 a little smaller so that you know that I'm just writing that as a base 3. And that 3 is not part of the logarithm, it is the base. All right, let's go for example 3. I'm going to rewrite the 1/2 right here. Okay, so that's gone. I'm going to rewrite the 4 there. So that's gone. I'm going to rewrite the 3 there. And that's gone. So now when I write my answer, it's going to be one single ln. And anything that's added is going in the numerator. So the 2 and the a to the 1/2 are going to go in the numerator. But I'm not going to write a to the 1/2. What am I going to write? A to the 1/2, I'm going to rewrite that as a square root of a. So 2 square root a in the numerator. And I got b to the 4th, c to the 3rd in the denominator. And that's my answer. Okay, keep on trucking. Put a 4 there, mark that out. Put the 2 there, mark that out. Put the 3 there, mark that out. I have one single ln. D to the 4th is the only thing in the numerator because everything else is subtracted. In other words, everything else has a minus sign in front of it. The d to the 4th is the only thing that doesn't have a negative or a minus sign in front of it. So that is in the numerator, but the a, the k squared, and the m cubed are all in the denominator. All right, example 5. The 2 is going to go here, and the 1/3 is going to go here. So it's going to be one single log base 3, and the x squared, and the x plus 2 to the 1/3. Since both of them are added, I don't have a denominator here because nothing's subtracted, so nothing goes on bottom. But it's just going to be x squared, and instead of writing x plus 2 to the 1/3, what am I going to write? I'm going to write the cube root of x plus 2. And that's the answer to that. Okay, let's rewrite that 1/2 right here. Let's rewrite that 3 right here. And again, I just really don't like that they wrote a base 10. It's not really wrong. It's just not, it's not a conventional way to do things. It's not how you should do it. So we're not going to write a base 10. We're just going to write log without a base because it's understood to be a base 10. So when I write this, it's going to come together as one single log. And instead of writing x to the 1/2, I'm going to write square root x and then x plus 1 cubed. Yeah. Let's try example 7. I'm going to move that 2 here. And so my answer is going to be log. The x plus 2 squared is going to go in the numerator, and the x is going to go in the denominator. That should be good for an answer. All right, last examples. Let's take that 1/2, put it there. Let's take that 2 and put it there. So now this is one single log base 8. And on the top of that fraction, I've got a 3. And I've got a square root x. Because of that 3 right there and that x to the 1/2 right there, they're both added. They're both positive. In other words, they got a plus sign in front of them or a positive sign, understood. So they both go in the numerator, and the thing that's got a minus sign in front of it, the 3 squared, goes in the denominator. But now I can actually reduce that a little bit, right? Because 3 squared is 9. I'm just going to rewrite that as a 9. And the 3 and the 9 can reduce each other. So it becomes log base 8 of the square root of x over 3. Because the 3 and the 9, that 3 cancels out completely, and that 9 becomes a 3. All right. Number 9. Rewrite the 3. Rewrite the 1/3. Rewrite the 2. And rewrite the 3. So this becomes one single log. What all is in the numerator? We just got a x cubed and a cube root of x minus 1 in the numerator. And I've got a 9. 3 squared, I'm just going to write that as a 9. Just going to keep that 3 squared as a 9. And I've got an x cubed on the bottom as well. So then that allows me to come over here to the homework problem and say that log base a of m times n is log base a of m plus log base a of n. That was very simple. All right, I'm not even going to bother to do that one because you will know how to do it. Here we're just going to move the r in front of that log base a, so it's r times log base a of m. All right, simplify the logarithmic expression. That means we're just expanding it, so we're taking the 5 in front of the log base 3. So it'll be 5 log base 3 of z. Moving on. Okay, this is more expanding logs, so I'm not going to do these because I've already done so many examples of this. Here we're condensing those logs. Again, I'm not going to do that because I've already showed you many examples. Solve the log equation. I've already showed you how to solve log equations. Here, this one is actually, it might look a little trickier, but it's actually really easy. So we want to solve this log equation, meaning we want to get rid of that. We were trying to get x by itself, so we need to get rid of the log base 9. So how do we do that? We do that by exponentiating with a base 9, with a big base 9 on both sides, and that cancels out both log base 9s. And so we're just left with x plus 6 on the left side, and we're just left with 7 on the right side. Now it's a very simple linear equation where you just subtract 6, and you get x equals 1. And that's that. Now here is a nice log equation where we actually have to do something I haven't shown you yet, but it's going to be applying what we learned about condensing logs to solving this equation. See, this equation has 2 logs in it, and so what I would like to do, the best way to do this, I think, is to condense these 2 logs into a single log, and then I can get rid of that log. But I can't get rid of both of those logs at the same time. So I'm going to condense them into a single log using what I've already shown you how to do. These 2 logs are added, so I condense them by multiplying their logarands. So it's condensing into a single log, and now I'm multiplying the x with the x minus 48, and so that's going to have to distribute and become x squared minus 48x, and that still equals 2. From there, you can get rid of the log. How do you get rid of that log? What's the base on that log understood to be? It's understood to be 10, so I get rid of it by using, by exponentiating with a big base 10. I'm going to exponentiate both sides with a big base 10. It's going to cancel out that log. That's understood also to be a big base 10. So that gives me, on the left side, it gives me x squared minus 48x equals, on the right side, 10 squared is 100. And now I've got to solve this quadratic equation, which you already have the skills to do. I would do it by moving the 100 over here with my other 2 terms, and then trying to factor. X squared minus 48x minus 100 equals 0. And so now, if I can't factor it, I'll have to do, the quadratic formula, but I believe this one will factor. What multiplies to get negative 100 and adds to get negative 48? I believe that would be a negative 50 and a positive 2. So I solve both of those, I set both of those equal to 0, and what do I get? I get positive 50 and negative 2 as my answers. But then I have to, as I told you before, sometimes it just doesn't work out right. Plug the 50 in up here for x and see if it works out. All I really mean by that, all you really have to do is to say, does it make the logorand in the original problem become 0 or negative? Well, if I plug 50 in here, that's not 0 or negative, that's just 50. If I plug 50 in here, that's going to make that logorand become 50 minus 48, which is 2. That's not negative or 0 either, that's positive, so that's fine. So 50 should work. 50 is a good answer. What about the negative 2 though? If I plug negative 2 in for x, that's already a negative number, that won't work. And if I plug it in for that x, negative 2 minus 48 is negative 50, so that won't work either. So negative 2 just doesn't work at any rate at all. The 50 is my only good solution. So 50 is the solution, negative 2. Even though it kind of works on paper, it doesn't work in the original problem as written. All right, I want to show you 2 ways to solve this one. We've already shown you one way, and that is if you're solving an exponential equation, you're going to have to use a log. We're going to get rid of that 8, and we do so by using a log base 8. That cancels out the exponential base 8. So we have x minus 3 on the left side and log base 8 of 64. That actually is just you can do that in your head or do that in your calculator. Log base 8 of 64, the exponent on 8, that gives you 64. That's 2. Then add 3 to both sides. X equals 5. That's one way to do it. But let me show you another kind of neat way to do this problem, in case you ever run into one like this. another way to do it. You could rewrite both of these in terms of their highest root. The largest common root between an 8 and a 64 is an 8. Now you could also use a 2 because a 2 is a common root as well. But using the largest common root makes it a little simpler. Because we can just keep that 8 as it is because it's already 8. So leave the 8 as 8 to the x minus 3. But you can rewrite the 64 as 8 what? As 8 to the what? 8 to the second. Now you got 8 to this equals 8 to that. That means this and this have to equal each other. So you just set those equal to each other. Or another way to say it is you could do log base 8 on both sides. And it cancels out both of them, so you just get x minus 3 equals 2. And so that's another way you can go about solving problems like that where you have a common root for the left side and the right side. Okay, I know we only have 2 more problems, but I think that's where I'm going to stop it for part 3. Because in part 4, I really want to make a video for you for probably what could quite possibly be the most important, most valuable, most life-changing lesson that you could ever learn in a math class. I'm serious about that. What you will see in part 4, I'm going to teach you about how money can work for you and how it can change your life and the life of your family and the legacy you leave after you. So I'm leaving you in suspense here, and I'll see you again in part 4.